We are going to see some basic concept like type of kernels, eigenvalues, eigenfunction, convolution integral, L2 function. Types of kernel: separable and or degenerate kernel. The kernel K S, T is an integral equation is said to be the kernel K S, T in an integral equation is said to be separate or degenerate kernel if it can be expressed as K of St, which is equal to summation I is equal to 1 to n ai of s bi of t, where a are functions of s only and b's are functions of t, right, t only. Also a's are linearly independent. So for example, if k s, t, k of s, t is equal to s plus t, right? So here you can take a1s is equal to s and b1t is equal to 1, right? a1s b1t first term, that is s. Second term a2s is equal to 1 you take, and b2t is equal to t plus a2s plus b2t. So it can be written as summation of I is equal to 1 to 2 ai of s bi of t, right? So this is separate or degenerate kernel. Then kst, right, it is equal to, right, summation of I is equal to 1 to 2 ai of s bi of t. So it is separable kernel. Symmetrical kernel: suppose kst is a complex valued function, right? It is a complex valued function with k star is its complex conjugate. If k s, t is said to be symmetric kernel or Hermitian kernel, then k s, t which is equal to k star t comma s, right? Suppose k s, t, right, k of s, t is a real valued function, then k of s, t is said to be symmetrical kernel. Then k of s, t is equal to k of t comma s, because its conjugate of k is k itself, right, because it is a real valued, right? So example, take k of s, t is equal to st, then k of t comma s is equal to ts is nothing but st, therefore k of s, t in the real case, right? Hence k s, t is symmetrical kernel. Eigenvalue and eigenfunction. In an integral equation, eigenvalues are the scalar values or a parameter lambda, it is denoted by lambda, for which a non-trivial solution exists, right? So for each lambda, so you will get a non-trivial solution for that integral equation, right? Then they are called eigenvalues. Eigenfunctions are the corresponding non-zero functions that satisfy the equation for a given value. For the given value, that is for the given value, there exists a non-zero function. If there exists a non-zero function that satisfy the integral equation, then that is called eigenfunctions. Consider the homogeneous Fredholm equation g of s is equal to lambda integral a to b k of s, t g of t dt. Here lambda is the eigenvalue and g of s corresponding to lambda is called, suppose if you put lambda is equal to some value, then you will get g of s, right? Then g of s corresponding to that lambda is called eigenfunction or characteristics function, right, with respect to that lambda. Next, convolution integral. The convolution of two functions k and g is defined by integral minus infinite to plus infinite k of s minus t g of t dt is equal to integral minus infinite to plus infinite k of t g of s minus t dt, right? So it is denoted by k star g of s. In particular, integral 0 to s k of s minus t g of t dt is equal to integral 0 to s k of t g of s minus t dt. So there the limit is infinite, minus infinite to plus infinite. This is a definite integral, this is, right, 0 to s, right? So example, consider the function x of t is equal to 1 for every t and y of t is equal to e power minus t for every t. Then the convolution of x and y is given by x star of yt equal to integral 0 to infinite x of s y of t minus s ds. So this is t, this is x. So O is the origin. So taking the mark unit 1, so this is x of t is equal to 1. We know the line equation. So function x of t is equal to 1, right? This is the function. Now you take another one, that is we are going to see e power minus t. So this is e power minus t. This is y of t, right? Function is y of t. So two different function. We are going to see the convolution, right? So x star y of t is equal to integral 0 to t x of s y of t minus s ds. So substituting the values, so you will get e power minus t, right? E power s integral 0 to t, lower limit 0, upper limit t, right? So e of minus t, so upper limit e of t minus e of 0, so 1 minus e of minus t, right? Convolution of the function x and y is 1 minus e power minus t. So it will be like this, right? X convolution y, the function is like this, right? 1 minus e power minus t. So if you combine so convolution of two function, that is 1 and e power minus t, you will get 1 minus e power minus t, right? L2 function. A real or complex valued measurable function f is square integrable function, then it is called L2 function. What is mean by square integrable? F is measurable function for which the integral of the squares of the absolute value of that particular function, that is called square of the absolute value, that is called square integrable. So integral mod x square dx, right? That is called square integrable. If it is a finite value, suppose if you are having f of x mod f of x square integral mod f of x square dx, which is less than infinite, that is a finite value, some value, then it is called L2, right? Integral, then it is called L2 function. F is called L2 function. Note, a measurable function is a function f between two measurable space x and y whose pre-image of any measurable set b is also measurable, right? That is, if f is a function from x to y is measurable, then for every measurable set b in y, right, the pre-image f inverse of b, right, is measurable in x, right? Consider the function f of x is equal to 1 by x power p, where p is less than 1 by 2, defined in the interval 0 to 1. So integral 0 to 1 modulus f x square dx is equal to integral 0 to 1 by x power p modulus, that is the square dx. So this can be written as integral 0 to 1 x power minus 2p dx. So we can integrate x power minus 2p, right? So you will get a finite value, right? So hence f is a L2 function. Next example, consider the function f of x is equal to 1 by x power 1 by 2 defined in 0 to 1. So taking 0 to 1 integral modulus fx square dx is equal to integral 0 to 1 by x power 1 by 2 square dx. So it is equal to, taking square root will cancel. So dx by x, integral 0 to 1 dx by x. So that is log x 0 to 1. So log 1 minus log 0 minus log 0. Log 0 does not exist. So it is not exist. So it is not a L2 function. Thanks.